Hi everyone, welcome back to Amber Electrical Solution, your go-to YouTube channel for EV charging, solar system design, and AutoCAD-based electrical solutions. In our previous video, we discussed the calculation, sizing, and selection of a solar charge controller for our 5 kW solar-powered electric vehicle charging station design. If you haven't seen that video, make sure to check it out after this one. Today, we are moving forward to the next key component: how to size and specify the solar inverter for our 5 kW solar-powered EV charging system. Before we start, don't forget to subscribe to Amber Electrical Solution and hit the notification bell so you never miss an update. Why we need solar inverter for our design. Importance of solar inverter in solar EV charging stations. The solar inverter is the heart of any solar power system. For EV charging stations, its roles are even more critical. Let's see why. 1. DC to AC conversion. Converts the DC output from solar panels into AC, which is required by level 2 EV chargers. 2. Grid synchronization. Integrates with the utility grid and ensures a stable, uninterrupted power supply. 3. Efficiency optimization. Maximizes energy conversion efficiency and boosts EV charging performance. 4. Voltage and frequency control. Maintains steady voltage and frequency, ensuring safe charging for electric vehicles. So the solar inverter is fundamental system component for our solar-powered electric vehicle charging station. How we can select the best type of solar inverter for this design. Let us see the type of inverters. Types of solar inverters and applications. Let's take a quick look at the three main types of inverters used in solar systems. Grid-tied inverter. Connected directly to the utility grid. No battery backup. Best for areas with stable grid supply. Application: homes and commercial buildings with net metering systems. Off-grid inverter. Works independently from the grid. Requires battery storage to supply power. Ideal for remote or rural areas. Application: cabins, rural homes, or areas without grid access. Hybrid inverter. Works with solar, batteries, and the grid. Supports backup power during outages. Ensures continuous energy supply. Application: EV charging stations, commercial and residential solar systems needing flexibility. Therefore, based on the types of inverters as we have discussed here, we can select the types of inverters for this work. Best inverter type for our design. For our 5 kW EV charging station, the hybrid inverter is the best choice. Here's why. Supports solar plus battery plus grid operations. Provides pure sine wave output, safe for EV chargers. Offers high efficiency between 90 to 96%. Enables automatic and seamless power switching. Before calculating and shing of the inverter that will suitable for this solar-powered electric vehicle charging station, let us see the system components for the entire system. System overview. Let's take a quick look at the key specifications of our design. System load capacity, 5 kilowatts. Daily energy consumption, 20.4 kilowatt-hours day. DC input voltage, 48 volts battery bank or MPPT controller. AC output voltage, 220 volts, 230 volts ideal for level 2 EV charging. Charger rating, 32A. Therefore, based on our system parameters, let us calculate and select the inverter size and recommended type for our solar-powered electric vehicle charging system. Inverter sizing considerations. Let's go through the key factors we considered for sizing the inverter. 1. Efficiency factor. Inverter efficiency typically ranges from 90 to 95%. We're assuming 92%. 2. Safety factor. We use a 1.25x safety margin to ensure reliability. Required inverter power calculation. The power supplied by the inverter or power of inverter equal to the average load that is required, such as 5 kilowatts power divided by efficiency of the inverter, such as 0.92 we have taken for this design, and time by safety factor of 1.25, which gives 6.8 kilowatts. Therefore, minimum SHI of inverter is our 6.8 kilowatts is required. Result: we need a 6.8 kilowatts inverter, so we round up to a 7 kilowatts inverter for safety and flexibility. For this design, We recommend the inverter type based on the analysis of each types of inverters and the calculations. A hybrid bidirectional solar inverter is best for this setup. Y supports solar, battery, and grid operations. Offers pure sine wave output required for EV chargers. Compatible with MPPT solar charge controllers. Efficiency range 90 to 96%. Seamless power transition between sources. Let us see the key features of the recommended inverter, which is selected for our design based on the above calculations and sizing of the solar inverter. Power rating 7 kilowatts. Input voltage 48 volts DC. Output voltage 220 volts, 230 volts AC. Waveform pure sine wave. Protections: overload, short circuit, surge, temperature. Battery compatibility 48 volts lithium-ion or lead acid. So based on this, the suggested inverter models. Here are some top-rated 7 kilowatts hybrid inverters suitable for our project. Grow at SPF 700TL HVM. Victron Energy Multiplis II 7 kVA. Schneider Connext XW 7048. These models are known for reliability, high efficiency, and compatibility with level 2 EV charging. Let us summarize the work today. The main features of the selected solar inverter is as follows. The 7 kilowatts hybrid inverter is the best fit for our 5 kilowatts EV charging station design. It provides high efficiency, reliability, and uninterrupted charging. It also future-proofs your system with solar, battery, and grid compatibility. Always invest in a high-quality inverter to ensure long-term performance and protection. Thank you for watching. If you have questions and comments, please drop them in the comments below. Don't forget to subscribe for more videos on EV systems, AutoCAD design, and solar solutions. Hit the notification bell to stay updated. Like, share, and engage for more technical insights.